All right, hello again. Well, okay, now that we figured out how to rotate our coordinates into the new coordinate system, we want to do that to points that we don't know what the new rotated coordinates will be. Right on point two, we already knew what they would be because they were given. Right, but you have to kind of look at this diagram to kind of see why that works. Right, what do we have to do to rotate these coordinates in? And what is it? It's adding this rotation to your retracement survey azimuth to get to your the needed azimuth. Right. So in this case, our rotation is 14.5 degrees, and you can use any rotation point you want. You can use it. You could start the rotation at 2, right? Because 2 is already rotated in now, or you could start it at 1. Right. I'm going to use point 1 to rotate point 3 and point 4 into our new coordinate system. Right. So what do we have to do to solve this? Well, we need to inverse point 1 and point 3 to get the azimuth, uh, the magnetic azimuth, and then whatever that magnetic azimuth is, we have to add 14.5 degrees to it to get the true azimuth, right? The grid azimuth. And then once we have the grid azimuth, we can use trigonometry with the distance measured in the field to solve for its new coordinates. Right, so I inverse from 1 to 2, so the azimuth from let me see here. I'm sorry, not 1 to 2. Azimuth from inverse from 1 to 3. 1 to 3. Right, and the azimuth before the rotation is 93, 41, 14. And if you inverse from 1 to 4, the azimuth is equal to 133, 49 minutes, and 57 seconds. Alright, so that's before the rotation. So we want to add 14.5 degrees to these azimuths. So from 1 to 3, right, new is going to be, change the color here, is going to be 108, 11, 14. And from 1 to 4, it's going to be 148 degrees, 19 minutes, 57 seconds. Alright, so these are our rotated grid coordinate azimuths. So rotated grid azimuths. So what we want to do is apply the change in northing and easting using this azimuth to point 1 to get to point 3, right? And we want to do the same thing to the coordinates to point 1 to get the new coordinate to point 4. Right, so you guys can, I already did the math but if you want to inverse from 1 to 3, right, you just use these coordinates up here. You inverse these 1 to 3, and you inverse 1 to 4, right? And you should get these 93, 41, 14, and 133, 49, 57. And then all you have to do is add 14 and a half to each one to get your new rotated azimuth. Since you need your distance too, right? When you inverse from 1 to 3, also inverse to get your distances. So from 1 to 3, the distance is 2. Oops. Distance is 2,861.403, and it's from 1 to 4, 3,444.527. Alright, so we're going to now use trigonometry to solve for our change in northing and easting. Alright, so here we go. Okay, so our distance, so from this is 1, and this is 3, and this distance is 2861.403, and this angle is the difference between 180 and 108, 11, 14, which is 71, 48, 46. Right, and if you take the sine of this angle and multiply it by this distance, you get 2718.452. Right, and that's a positive, right? From 1 to 3, you're adding the easting, right? And if you take the cosine of 71, 48, 46, multiply it by 2861.403, you get negative. Well, you don't get negative, but you want to subtract the northing, right? We're going down. You get 893.110. Alright, so now you want to take your coordinates to point 1, which are 28, 248, and the northing is 28,248 minus, oh, I'm sorry, yeah, northing minus 893.110. And that is equal to 27,354.890. Alright, and then easting to point 1 is 33,289. You want to add 2,718.452. And that's going to give you 36,007.452. Alright, so that's your new state plane coordinate, northing and easting, for point 3. Alright, and now we're going to use a little trig and do the same thing for for 0.4. Alright, so let's get the triangle set up here. Alright. Right, so this distance is 3,444.527. So 3,444.527. And the angle, if you take the difference from 148.1957 to 180, it's 31. This angle is 31.4002. Well, this video is getting kind of long, so let me stop here. Next video, I'll do this trig out, and we'll calculate the new coordinate, and then we'll check to make sure the this rotation worked. See you next video.